Hello students, today we are going to discuss about the topic called three variable map. The three variable map is used to represent a function with three variables. Whenever a boolean function is having three variables, then the possibility of minterms, the number of minterms possible can be 2 power 3, which is 8. So there are 8 minterms for 3 binary variables. Therefore, the map consists of 8 squares. Here the minterms are not arranged in a binary sequence, but in a sequence similar to a gray code. The characteristic of this sequence is that only bit changes in value from adjacent column to the next. Means, let me explain you in detail. So as I said, a pre-variable map consists of 8 minterms. Why 3 variable means whenever a boolean function is having 3 binary variables, the possibility of the map k map is 8 minterms, means a map consists of 8 squares. Here the minterms are not arranged in a binary sequence, means 0, 1, 2, 3, 4, 5, 6. Likewise, they won't be arranged. It is arranged according to the code called gray code fashion. What is a gray code? We have discussed about gray code in unit 1. Gray code is also known as a reflected code. Gray code is also known as a reflected code, means whenever if you take the difference between two consecutive numbers, the difference between the previous number and the next number is only a 1 bit, means a 1 can be turned to a 0 or a 0 can be turned to a 1. So whenever you want to arrange 3 variable map in 8 minterm fashion, we arrange according to the gray code sequence. How we are going to arrange, we will see in the example. Okay. So the characteristic of this sequence is that only one bit changes from 1 to 0 or from 0 to 1 in the listing sequence. So the map we draw is marked with the numbers in each row and each column to show the relationship between the squares and the three variables. Okay. For example, see here the square assigned to M5. Able to see, this is M5. Okay. So when coming to the next one, this is M5. Okay. The square assigned to M5 corresponds to row 1 and column 01. The square assigned to M5 corresponds to row 1 and column 01. So together 101. So what it is called? 101 means the value is 5. That's why we have designated this particular square as M5. Okay. So this is the way how we are going to write the three variable map. So in the earlier class we have already seen how to represent two variable k map. See here directly we have written two variable. M0 means 0 0, M1 0 1, M2 1 0, M3 1 1. If you take two consecutive numbers, there is only one bit difference. 0 0 is turned as 0 1, means a 0 is turned to 1. Okay, here 0 1 is turned to 1 0, means only 0 is turned to 1 here. When coming to here 1 1, a 1 is turned to 1. So that we have written here in a binary listing sequence like 0 1 2 3. But whenever you want to represent in three variable, that is not possible to represent in binary sequence. See here 0 0 is 0, which is M0. 0 1 is 1, which is M1. 1 0 is 2, which is M2, and 1 1, which is 3, which is M3. If you observe, according to binary listing sequence, we have to write 0, 1, 2 and 3. But here we have written vice versa. We wrote 2 here and we have written 3 here, because here we are following the concept called gray code. If you observe, 0 0 is the first term. Okay. When coming to next one, this 0 is changed to 1. Only one bit change. Okay. If you write M2 here, this 0 1 will become 1 0, means 0 will be turned to 1 and 1 is also turned to 0. Okay. That is not acceptable in the method called K-map. Only one bit difference must be there according to gray code method. So see here Here 1 remains the same, 0 is turned to 1. Okay, here 1 remains the same, 1 is turned to 0. That's why while representing the minterm designation, we are representing as M0, M1, M2 here and M3. In the same fashion, M4, M5, M6 here and M7. We have seen taken as x and y here, 0 and 1 values. But here we have three variables, x, y and z. Okay, see here in one column we have taken x variable 0 and 1. In this row we have taken y and z. This is y. Let me change. This is y, it's not xz ma. Okay, kindly observe. Okay, see here 0 and here I am taking it as 0 and 1. 0 0 0 1 1 0 and 1 1. So based on this, now I am going to write the values of the three binary variables x, y, z. See here 0 0 0 x bar, y bar, z bar. 0 0 1 x bar, y bar, z. 0 1 1 x bar, y, z. 0 1 0 x bar, y, z bar. The same way 1 0 0 x, y bar, z bar. 1 0 1 x, y bar, z. 1 1 1 x, y, z and 1 1 0 x, y, z bar. This is how we are going to represent K-map or map method for three binary variables. For a Boolean function which is having three binary variables, this is the method which we are using to represent K-map. Whenever we have n binary variables, there are 2 power n minterms possible to represent in K-map. So whenever we have two binary variables, 2 power 2 which is equal to 4 squares or 4 minterms possible for K-map. Whenever we have three variables which is 2 power 3 which is equal to 8 possible squares for three variable map. Okay, so this is, we have minimization procedure for solving the Boolean expression. Why we are using K-maps here? In order to reduce the number of min terms in a given Boolean algebraic expression. Whenever a Boolean algebraic expression is having 10 to 12 min terms, okay, that can be simplified using this K-map method. How we are going to simplify means based on the number of the binary variables in the given algebraic expression. If the given algebraic expression is having two binary variables, we minimize it using two variable K-map. If it is having three variables, we minimize it using three variable K-map. So what was the minimization procedure for using this three variable K-map? See here. The combination of the adjacent squares is useful during the simplification process and is easily determined from inspection of three variable map. Whenever a Boolean function is represented using a K-map, okay, whenever the given minterm is there in the given function, we place a 1 in the square. Okay, whenever it is possible, okay, by taking the adjacent square values, we can minimize the given Boolean function. So how we are going to take the adjacency means, each square represents one term, one minterm, giving a term of three literals. Okay, if it is only a 1 in the K map, for suppose in this K map there is a 1 here. Okay, so whatever variables available here, x and here yz is available, just take the directly it as xyz. Okay, so two adjacent squares represent a term of two literals, means whenever there are two ones in the given K map, for suppose M3 is having a 1, M2 is having a 1. Okay, from these two, only two variables will be considered for minimizing the Boolean function. Whenever there are four adjacent squares, we represent a term of one literal. Okay, whenever we have four adjacent squares, whenever we have eight adjacent squares, we represent the function directly equal to 1. Means how we are going to simplify the Boolean expression means, If the given Boolean function is having only one minterm, directly we write the output of the Boolean function with the given minterm. If at all the function is having two adjacent squares, we write the Boolean function output with two literals. Means xyz plus x bar yz bar is the given function which are adjacent squares. Okay, we'll write the result with two literals, either xy or yz. If we have four adjacent squares, we represent with only one literal. Okay, means we have four adjacent squares once, we represent it as like only one x or y or z. Whenever there are 8 adjacent squares, we represent the function directly equal to 1. Let's see an example for minimizing the Boolean function, then you can understand easily. See here, the given function is f of x by z is equal to sigma 2, 3, 4, 5. The representation here is sigma. Whenever it is sigma, this is called sum of minterms. What it is? Sum of minterms. So whenever, okay, first draw a Carnot map. After seeing the number of variables are 4. So we need a 3 variable map. Okay, so given number of variables are x, y and z. By looking at the function, we require a 3 variable map to simplify or minimize it. Okay, so take 3 variable k map. Okay, this is x and this is my yz, 0 and 1, and write the values. So what are the values? 2, 3, 4 and 5. What is 2? M2. Here place a 1. M3 place a 1. M4 place a 1. M5 place a 1. Okay. Now, according to minimization concept, take the adjacent squares. See here, these two are adjacent and these two are adjacent. Okay. In these adjacent squares, which is common? 1, 1, 1, 0. Which is common here? 1 is common here. 1 means what here? Y. 1 is what here? Y. So take that common value and write the complement value. So in this 2, okay, whenever there are two adjacent squares, the output can be written with two literals. That is our minimization procedure. Given variables are 3, but the output can be two literals because we are having two adjacent squares in the given K map. So x bar, because this is in the x row, x bar plus, which is common value here? Y. So which is common? Y as taken. This z value will be discarded because we are taking the adjacent squares. Again check for the adjacency. Here also again we have adjacency 0, 0 and 0, 1, which is common. Again y is common. Y is 0 here. Again in this column also y is 0. 0 means what? Complemented. So take x y bar. We are here in x column, x is 1, so x y bar. So this is the given function. After simplifying it, we got x bar y plus x y bar as the minimized Boolean expression. This is the way how we are going to simplify the given Boolean functions using map method or K-map method. Let's see the other example in next class. Thank you.